Great. I think we've got a good number of people in the room now, so we can kick things off. I just want to thank everyone for joining us today for our webinar on printing electronics with flexible inks. Very excited to have you all here. I'm just going to kick off by muting all of you just in the chat, just so that there's no distractions for us. So just bear with me as I do that. And Andy, you'll probably just have to unmute yourself when you go to present as well. And that's my big spoiler here. Today, yeah, we're joined by Andy from ACI Materials. He's their application engineer manager, so we're very excited to have him here presenting as well with us today. Yeah, to start off, I'll just go over the agenda for today, and then we'll kick into things. So I'm just going to briefly start with 2 minutes of announcements, a brief couple of things that are happening with Nova over the next couple of weeks. Then I'm going to hand things over to Andy from ACI, and he's going to present on ACI's line of Alchemy conductive inks. I got a bit of a glimpse of it yesterday as we were rehearsing, and it's really informative, a lot of great stuff packed in there, so should be really exciting for all of you. Then we're going to transition over to a print demo where we'll be doing a calibration using one of ACI's inks. We're going to use their stretchable carbon 1502 for you guys today. And then we should have time at the end for Q&A. And that being said, feel free to ask questions throughout the presentation as well in the chat. We've got a few folks from Voltera here. They've all got Voltera listed in their name to help answer questions. And I think there's a few folks from ACI as well, also with ACI or ACI Materials in their names. So feel free to be asking those questions throughout. But yeah, we'll get some time at the end to answer some questions from that chat. And I do want to say as well, stick around to the end of the webinar. We'll be sharing an exclusive promo code that you can use towards a purchase of Nova. So yeah, you want to hang around to the end for the Q&A for that. Perfect. So without further ado, I'm going to kick into a quick couple of our announcements here. One new thing that's happening here with Voltera is we've got our prototyping service launching next week. So with this, we'll be able to print some of your designs, and it's really cost effective for you and really precise. And some of the key benefits to our prototyping service is you can get quick prototypes of your designs, eliminate the material handling and storage on your end. You don't have to deal with tools or screens, and we're not looking for any minimum quantities. So yeah, it's a great way for you to dive into printed electronics, see if your project is the right fit. So yeah, check out our website next week for that launch, and our website is just voltera.io. The other announcement I have is more inks on our store next week. So yeah, that's right. We'll be offering a few more inks on our store for inquiry. We're going to be carrying these in a little bit lower quantities than our regular inks that we carry. So for the time being, there will be a form to fill out to inquire about availability and what quantities you're looking for. And from there, our sales team will reach out with those available options. But yeah, really excited to be offering a few more inks next week as well. And then I do want to say, yeah, if there's anything in our presentation that we don't cover today on Nova that you were looking for specifically, you can always reach out to our sales team for any questions you have. And that's sales@voltera.io is the best email for that. Or you can reach out in our little chat bubble in the bottom right-hand corner of our website. So yeah, awesome. So as of right now, like I mentioned, we've got Andy here from ACI. He's got a great presentation for you guys on their Alchemy series inks. So really excited to have you here, Andy, and I'm going to let you take it away. So yeah, welcome.
Awesome. Thanks, Nathan. And thanks for having me here today to talk about our Alchemy inks. You can see my screen, yeah?
Looks great.
Okay, great. Okay, so going into the presentation on the Alchemy inks, the electronic material is made to innovate change in electronics manufacturing. So I'll first go into how we manufacture our inks here using our cavitation process. So basically what this picture represents here is kind of our enclosed system that we process our inks in, which is a great benefit because traditional mixing methods would typically be open to the environment. So you get like, volatiles coming off on a 3-roll mill, or you have to use media that is challenging to use when you're milling product or milling particles. In our process, it's a very precise way of dispersing and deagglomerating, and we basically control the expansion and collapse of vacuum bubbles inside of our process at very high pressures. And when those bubbles collapse, they're going to be attached to these clumps of particles, and all the energy releases directly towards those particles. So you can imagine that this is a very precise way to control the dispersion, and then it also doesn't affect the morphology of the particles. So just really kind of a revolution in how to process and how to manufacture these inks in a more controlled environment compared to what's been done in the past. And then to kind of get into the alchemy inks specifically, we kind of have to understand first the different types of silver inks that are used. The probably more commonly used polymer thick film conductive materials are percolation conductors, where you're basically just relying on particles kind of touching each other that are suspended and held inside of a polymer matrix. So you don't get, as close contact and routes for electrons to flow as something like a centerable conductor, where you can see the packing is very tight, it's very dense. And so the centerable conductors are going to have much higher conductivity, but there's going to be other sacrifices, particularly in the print thickness that you can get with those. Typically, you're going to have a very thin conductive structure. And then going into the semi-centering conductors that we're making here at ACI, the Alchemy inks, those are kind of taking the best of both worlds, because percolation conductors have a lot more resin, so they do adhere better than the centerable. So we're kind of taking the best of both worlds and utilizing that in our semi-centering conductors. And this kind of just highlights some of the things that I just kind of spoke to, and that the cavitation really enhances conductive inks and sensing inks and carbon-based inks that are used for heaters. And we're talking about 4 to 5 times more conductive than you could ever get out of a polymer thick film conductor. And then here's a nice picture of one of our demos we make for LEDs and surface mount. So you can kind of see a nice flex. This is soldered on using our new durable low temperature solder. I'll get more into that later. But so why is it important, and like what are we doing different that wasn't already available? Well, so I think this picture over here of this micro BGA grid is a great example of what we can do that hasn't been done before. Because before, these alchemy inks, this would be a square patch of silver, and then they go in and laser cut the pads out. So we're able to just screen print to this size package, which is really kind of different and makes it more feasible to do a pure additive manufacturing process, not having to go and then laser ablate to get rid of stuff. And then these next two pictures are just more examples of how fine of lines you can print. And these are just on regular PET substrates, ST506. So you can see we print really nice, crisp features even through 20 micron openings. And this would be kind of an example of if you wanted to do some type of metal mesh for like a transparent application. And so why did we do all this is we really kind of found that we could come up with a way to replace etched copper circuitry, and still use traditional manufacturing methods by soldering to it. Conductive adhesives, you have trade-offs of environmental aging, not being great, the batch curing, the long curing, so your throughput isn't very good. So it's really been kind of out of graphs just to use the full ecosystem of people printing and then sending and getting that done at a PCBA house where they're just assembling the way they regularly do, solder reflow, and you're good to go. So it really kind of takes advantage of the additive side of printing the conductors and then the throughput of the surface mount and using the solder reflow instead of batch curing. And part of that really, the big push is because of all the excess waste that is associated with copper etch. So, just tons of waste streams that can be eliminated or greatly reduced because, there's probably going to be situations where you still need that, but replacing it with an additive process as much as possible can have a really great environmental impact as well. And here's a example of something that I was printing recently on the Nova. As just kind of an example of what we're doing here, using it to confirm designs before we actually have a screen made to go screen print. And so we wanted to kind of redo our demo, like the one you saw with the LEDs, and actually have like a BGA attached on there. So we found a really tiny 555 timer that we're going to be putting onto these pads here. And so it was really nice to be able to go and, try this out before I actually designed the screens. And we got some pretty nice line widths. This was using our Nova that we have here with the 50 micron Subex nozzle, printing with the FS0117 Alchemy ink. So we're kind of excited because this really, doing more than just discrete components really kind of opens it up of like, oh, hey, look, like you can put a chip on here. You can do a little more than we thought. And then going into the high performance materials and what you can use these for. One that we've seen is using the Alchemy for bus lines because of the high conductivity. You're able to pass a lot more current and run more power through the Alchemy at narrower trace widths. So being able to print that a little bit thicker as compared to like a nano ink where you can actually lay down 10 to 15 microns if you need to get better current capability without increasing your footprint as much. And then the advantages of being able to print right onto connectors rather than having a PCB that you then have to figure out how to connect to a biometric sensor or some type of sensor. It's a little more challenging on etched copper. And for the use on antennas and using it for sensors, the low topography and the definition of the Alchemy when it's printed has shown to be very, very smooth. So makes it a very good candidate for those type of applications. And over the years, we've always had the feedback that our inks, after our process of cavitating different types of materials for sensors or heaters or whatever the case may be, is that we show order of magnitude improvement because of our dispersion technology and how robust those inks and coatings become. And then in the wearable electronics, I kind of missed on talking about biosensors on the Voltera, but one of our consultants and persons that works on really pushing our wearable technology, Greg Novello, he's here in the audience today. That's actually him right there when he was doing some R&D up in the high mountains. And so we're really a lot of applications that you see in these examples here relate to biometric sensors, biochemical sensors. So we're going to be doing a lot of work here in the near future, in the upcoming weeks, actually, on doing some demonstrators for biometric sensors. And so Greg's pretty excited, and he's looking forward to using the Voltera. He's been really kind of itching to get that going. So we're pretty excited about that. But yeah. that's it. So, the materials that enable tomorrow's technology. That's what we're, trying to come up with methods to manufacture electronics in a reasonable way.
Awesome. Yeah. Thanks so much, Andy. Really informative, really great stuff there. It's awesome to see how far your materials have come just in the last couple of years as well. It's really broadened the horizon for varied types of applications, and especially, yeah, that last slide you're showing just some of the varied applications that you guys are working in. Just really cool stuff right now. Yeah, so really appreciate you coming and joining us and presenting. Again, keep those questions coming in the chat. We've got the folks at ACI. They're already answering. Our folks are definitely in there answering. I've been keeping a peek on the chat, and we'll have some time at the end for Q&A. So we'll be pulling questions from that chat there as well. So yeah, we're going to transition over to a quick demo, and we're going to be calibrating with one of ACI's inks. We're going to be doing the stretchable carbon, so the SC 1502 or 1502. Yeah, and I'm just going to kick in. So I've got the software up here for you folks. You've got a little bit of a view of Nova, and then you can see myself as well. Yeah, I just want to kind of introduce Nova's software here on my screen. If any of you are V1 users, this should be kind of familiar to you. We've got our three main workflow tiles in the center of the page for dispensing, so doing our prints. We've got our materials for our materials library, where all your personal materials are stored, as well as our Explore library. And then we have the calibrate procedure. And today we're actually going to be working through the calibrate procedure. So we're going to kind of treat the ink, the stretchable carbon that we're working with today, like we just got it in, and we want to figure out the print settings in order to actually do some prints with it later on. So to kick off the calibrate procedure, I just have to click on the calibrate, and I'm going to start a new one here. There we go. Perfect. So this is kind of the workflow view that it's going to look like in both the dispense and the calibrate workflow. In the dead center, you kind of get a good screenshot view of what the work area we're going to be printing on. So you can see this replicates the calibration plate here on our printer. And then on the left-hand side is where all of our user inputs are going to be throughout this process. So right now, we've got the calibration setup. And then in a few more steps, we're going to see some nice helpful tips and guides that pop up here in the right corner as well. So for today, if we're creating a new material, we can do that right here. So I just quickly need to give it a name. So being as descriptive as possible is always good for you to reference back. So like I said, this is the ACI SC 1502. And I like to put the nozzle that I'm using here as well. So I'm just putting a Nordson 200 just so that I know that. And then I can quickly categorize what this material is. Just with these subtypes, just helps us for organization once we get lots and lots of materials. And again, adding a quick description really helps out here. So just going to type that in here really quickly. Perfect. And I create it, and now I'm able to select it here from my list of materials. So you can see I've got my ACI with the NOR 200 that I've just created. And all of our information is stored in batches. So if you've got this batch in, and then in 6 months you get another fresh batch and you want to calibrate it differently, you can keep all the same parameters and just add a new batch instead. Now, one of the new features we added in a previous software update in version 1.8 was the ability to calibrate on your own substrate as well. So up till now, we've been calibrating mainly just in the calibration area on the stainless steel plate, which is great for most cases. But yeah, sometimes some materials you want to see how it's going to behave on the real substrate that you're printing on. So we've added the advanced option here where you can choose the substrate that you would like to print on. So I'm going to print on to PET today. And you can see that the work area has updated to reflect that as well here. So it's no longer showing the calibration plate. It's now showing the vacuum module plate here. Perfect. So I've got everything set up here that I need. So I'm just able to click next and move on to the next step. So one of the nice things about the working with your own substrates is you can kind of choose the grid size for calibration patterns that you want to print. This is because your substrate might be varied in size. You might have a couple inch by a couple inch size, or you might have a full sheet like I'm working with today. And so I'm able to either bump up the number of rows or bump it down to match what will fit on my calibration print. I think for myself, this is kind of a good size for what I'm working with here. It's going to give me 15 chances to work through my calibration of my material before I would have to kind of work through the substrate and find a new spot on the substrate to print with. So yeah, that should be plenty for now. So I'll click next. And now it's recommending that I mount the substrate. As you can see on my printer, I've already got the vacuum plate down and I've already put my sheet of PET down here. So I am ready to go on that side. So I will click next. And perfect. You probably can't hear it because I've got a noise canceling microphone, but now that we're doing alignment, the vacuum module did engage. So now my substrate is nicely secured in place. Now for this alignment step, if I was using a smaller piece of substrate, it would probably be more important for me to align exactly where that substrate is in the work area. For time today, I'm going to quickly skip through this, but we've got a couple other demos, webinars where we've gone through this, so feel free to check those out on YouTube as well. So I'm just going to skip through because I'm happy to print right in the center of our work area. The next step that is prompted for us here is probing our substrate. It's really important that we have a height map of our substrate here in order to print accurately at the height that we're going to set out. So I just need to ensure that our substrate is clean, and then I can start probing. And so we're going to see our probe interact with the XYZ positioner tool here in a second. So it's just going to find itself, and then it's going to move over to our substrate and start probing. And you can see on our substrate here, it's generated a grid of probing points based on the calibration patterns that we're going to be printing. And so, yeah. Basically, this is the grid that's created, and it's creating triangles in between, and we're basically interpolating the data in between those triangles to generate the full height map. This is a setting that can be adjusted on your substrate if you need a finer height map, more precision, or if you need less precision. So perfect. So our probe has just finished measuring itself at the XYZ positioner tool. So now it's starting to probe our substrate. And you can see as it probes, it highlights the probed points in blue. So they get filled in once they're done there. And there's a little bit more of a close-up shot of the probe doing its thing. And obviously, if you have a more fine resolution height map, there's going to be more probing points, so it's just going to take a little bit longer. So kind of the default setting here we have for the probe pitch of 5 millimeters is a good balance between accuracy and time as well. Perfect. So we've got everything probed, so I'm ready to move on to the next step. And so this step is a bit of an important step. It's where we're going to set the target qualities for what we're going to calibrate for our material. So by default, we've got a couple of nozzles here that you can pre-select, or you can open up the advanced options here and dial in the settings exactly the way you want. Now we also have a little bit of a graphic at the bottom here that's just going to kind of emulate what those settings might look like, and it'll give you warnings if your settings seem a little too unrealistic. But for me today, I am using a 200 micron nozzle. So I'm just going to put that in here. And I'm using a Nordson nozzle, one of their EFD nozzles. It's a straight barrel geometry. So I'm just inputting that there. And then I'm putting in my target trace width. So we can see that it's green here, but we're getting a little bit of a ballooning out shape. So I'm just going to increase my trace width a little bit more there to have it make sense. You can see, obviously, if I went too low, it's going to say, consider increasing the trace width here because this is probably a little bit on the unrealistic side. My nozzle's going to be an inner diameter of 200 microns, so it's pretty unrealistic that my material is going to come out less of a width than that. Perfect. And then we can adjust the print height. Again here, if I put something unrealistic, it's going to recommend that we adjust things. You could obviously continue on with this, but in this case, we want to make sure our print's going to stick. So I'm just going to go with 60 for now. And then the temperature option here, the default's 35 degrees Celsius. We have this set as the default just because it's something above room temperature. So if there's a variance in your lab day to day, or if the machine's a little bit warmer or cooler, that's not going to come into play. So you'll know that your print settings are going to be consistent from day to day. And yeah, we're eliminating that temperature variable. So with everything set here, I am good to move on. So I'm just going to click next. So it's giving me some instructions here on how to prepare my dispenser. I've already got it assembled and attached to Nova. You can see it on my screen there. But this is a great time to highlight some of these helpful tips and tricks on the right-hand side here of the software as well. So it's walking us through the process of assembling the dispenser fully. We also have some great support articles that take you through this process as well. And that's just at docs.voltera.io. Perfect. But yeah, I'm all set on this step, so I'm going to click next. Perfect. And you can see we had that temperature of 35 degrees Celsius set. So our dispenser is just heating up to get there. But this is a good time to kind of highlight what we're doing in this step. So this step is really just giving us a starting point for calibrating our material. So we just need to know a point where material is coming out of the nozzle. So we're basically going to be starting at 0 pressure and slowly incrementing by 50 until we get that flow coming out of the nozzle. And this just gives us, yeah, a good starting point that we can then do the rest of our calibration off of. So we should be kind of within the range of a couple hundred of where we want our pressure to be. So we can dial that in pretty quickly and then move on to calibrating some of the other things like starts and stops and leakage. Perfect. So I'm just going to click check. And we're going to see our dispenser move over to the XYZ positioner switch here in order to measure itself. So we can see it getting its Z height there. And then it's going to move in a second to get its X positioning. So it's going to tap on either side of the switch. And then we calculate the center based on that. And it's going to do the same thing in the Y direction there. And once it's done, we'll know exactly where the tip of that nozzle is, and we'll be able to print with it. Perfect. So it's all set. And it's just going to move over to the calibration area here. And that's so it can start increasing the pressure. So that's what this little circle section is on the left, just a spot for material to be dispensed during the flow check. So I like to just put a little wipe underneath to keep my machine nice and clean. But yeah, so we're estimating pressure. So we've got, we're just waiting for material to be coming out the end of that tip to start flowing out. So we can see the pressure here on the left-hand side slowly increasing by increments of 50. Now, I've obviously done a practice run, so I have a good idea where the pressure should be on this nozzle. But one thing to keep in mind is nozzle geometry does come into play with your materials. So in this case, we're using a straight barrel nozzle. So it's going to actually have a lot of surface tension as the materials pass through it, because it's got a long straight barrel that the material has to go through. So it usually requires higher pressures in order to dispense that material. Whereas a conical shaped nozzle like the Suberex ones that we use for some of our other prints usually requires a little less pressure. Yeah, so making those choices can be determined by kind of the viscosity range of your ink. But can also come down to cost and just whether it will print. A lot of these materials especially from ACI, print great with both sets of nozzles. So yeah, it really comes down to what you're looking for and what features you're needing to print. Now I know we're still a little bit ways off, but you can see we're at about 3,800 pressure. Now in our last software update, we actually removed the cap at 3,000 during the calibrate procedure. So yeah, that's kind of why I went with a straight barrel nozzle tip today, so I could demonstrate these higher pressures that we're able to go to in the calibrate procedure. So the new cap is at 10,000, and we're going to get a little close to that, but not extremely close. So I do have material just coming out of the tip here, but it's just kind of balling up at the end. It's not quite flowing at this point, so you can kind of see it there. So I'm probably just going to let the pressure increase just a little bit more until I get a little bit of a flow. I'm just keeping an eye on it, and then I'm just going to hit the stop button or the space bar on my keyboard to stop it. So I'm getting a little bit more of a string now, so I think I'm good to stop it there. So we made it to about 6650. Perfect. And then the dispenser is just going to back off that pressure. And yeah, if we wanted to, we could recheck and start that process again. But in this case, I'm just going to clean off the tip of the nozzle, get that material out of there, and we can move on to actually calibrating. Perfect. So here we've got just a quick diagram of what this process looks like. We're going to basically print a calibration pattern. This is what it looks like over here on the left. We've got a series of lines, a series of pads, and then we've got this kind of square wave print. And then we're going to be given the opportunity to grade that pattern based on a few criteria. And then based on how we grade it, we'll have the chance to improve it by doing another print. And we can basically continue this cycle round and round and round until we're happy with the print settings, and then we can use them and save them. So yeah, we're going to kick things off by just hitting print, and our printer is going to go over and start printing on our substrate directly. And we don't need to keep too close of an eye on this because once Nova is finished printing this calibration pattern, it is going to take a picture with the onboard camera. So we don't need to squint our eyes or strain our necks looking over the machine. It'll handle that for us here in a second. Perfect. And we've got that picture here. Great. So we have ink dispensing, which is perfect. It's a great start. But obviously, we're not getting enough pressure going on here. But yeah, as we highlight our cursor over top of the image, we're able to zoom in a little bit more. And I'll just expand the pattern settings. So these are all the print settings available for an ink, but dialing in each of these can be really tricky because there's 10 of them. So really fine tuning the print would be tricky if we're just trying to adjust one of them at a time. So that's why we've got this kind of measuring criteria here on the side that you can grade your print with. So by default, we have the width, so the pressure setting. So we can say, hey, we need less pressure, or hey, we need more pressure. And we've also got the leakage. And then if we open up advanced, we've got a couple more options here. Now, I always recommend trying to dial in the pressure setting first and then moving on to fine tuning. Because we're really not going to see how much leakage is happening or if our starts or ends are really bad until we're kind of a little bit closer to that pressure range. So we've got the option to increase the pressure here by a couple, and we can keep going. So we get a few extra dots if we find that we're way off. So I'm going to try this. I'm going to try increasing it by a significant amount, and we'll see if the print is a little closer to what we're looking for. So I'll click improve, and I don't have to worry about wiping off the previous pattern. You remember that grid that we set out earlier on in this process. So this next print is going to happen just right next to the previous print. All right, so it's just taking its picture here, and then we can grade it again. So I think we're a little ways off still. So this would be an opportunity. I could go back to the estimate pressure step and go to a little bit higher of a pressure, but I'm just going to keep adding pressure here until I'm a little bit happier. So we'll just quickly keep going through this. And you can see the new dispense pressure we're working with here is about 7,850. Perfect. So we're getting a little bit closer, but we're still not quite getting full features. So I'm just going to go again really quickly here. I'll try increasing it by 3 this time and improve. But yeah, I think we're getting a little closer. The other thing to keep in mind is what's realistic for your material as well. Yeah, some materials are going to print with a certain nozzle or a wide variety of nozzles really well. And some nozzle or some materials are really going to prefer like a single inner diameter or a single geometry. So that's what this kind of calibration process can be really helpful for, is kind of getting a good guideline. And if we say, hey, you know what, we're getting really close, but not quite exactly what we're looking for, maybe we need to bump up a nozzle size or down a nozzle size or change geometry, we can quickly go back through this process. So we can spend a little bit of time fine tuning this and then be ready to go with our prints. Awesome. So we're almost there. We're getting our rectangles completely filled in. I think that's those little specks are actually just reflections from the lights. And then most of these lines we're getting on the square waves, we're getting connection, just a couple of little gaps. So I would bump up the pressure just by maybe 1 or 2 here again and see how it goes. Now we are getting a little bit of a blob at the start of our traces here. So we could work on that. So there's kind of 2 directions we could go. It could be leakage, and this is a great place to highlight kind of the help section here as well. So you can click on the question mark beside any of these to get the definition and the recommendation of what to do to what you're seeing. So for leakage itself, it's recommending that we decrease to reduce blobs at the trace starts or between traces, and increase if we're seeing the piston retract excessively. Now I was noticing the piston was it was moving kind of as expected, so I don't think we need to increase, and we are seeing a little bit of a blob. So yeah, it might be worth working on our leakage, but it could also be just our trace starts here. So kind of adjusting the threshold of when we're going to start printing our ink. But yeah, we could go for this and we'll click improve. And I think just for the sake of time, this will probably be the last one for today. But yeah, this should give you an idea of kind of how smooth and easy this process is to run through. And if we wanted, we could go back in, try this with a different nozzle, and yeah, see what different results we get. And yeah, spending maybe an hour working through this, maybe a couple of times with a couple of different nozzles will set us up great for lots of printing going forward. So yeah, that's kind of what this process is for. So yeah, we'll keep an eye on this print and see how it turns out. So it's grabbing the picture, and then we'll jump back over to the software here. So I think I could work on increasing the pressure a little bit more. And I would do that if we had a little bit more time in this webinar. But for today, I think I'm just going to kind of keep it as is. So once I'm happy with these print settings the way they are, I can just click the Save button here and work through it. But I also did want to highlight that maybe if I went too far and got past the point that I liked, I got kind of too down the road of nitpicking, I can always go back to a previously graded pattern and make adjustments off of that and try printing that one again as well. But yeah, in this case, I'm just going to say I'm happy with this. So I'm going to save these settings, and you can see that we now have all these settings saved for us with our material name. And yeah, we click finish and it's all set there. Perfect. And the last little bit is I just wanted to highlight the materials library so we can show that that material has been saved. So if I click on the materials tile here, we're given two options. So we have the Explore library and then the regular library. So this is where our materials are managed. So if I click on that, you can see the material I just calibrated is already highlighted here. And yeah, we can make adjustments on the fly as well to these settings. So they're not locked in. You don't have to just do the calibrate procedure to make some fine tweaks. You can do that while you're printing as well. So yeah, we could adjust any of these at any point as well. And lastly, just the Explore section. So this is where we keep kind of the materials we've been using a lot in-house for you guys to add to your store as well. So for example, we've got like a substrate here of TPU. So you could add that to your device, and then it's in your library. So if we view it in the library, we can see that it's been added to our own here as well. Perfect. So yeah, that concludes the demo portion for today. So I'm just going to switch back here. And yeah, we'll kind of open up the floor to Q&A here. So yeah, we've got Andy and myself available here. We've also got the folks in the chat. So let me just bring up the chat on my end. And I'm assuming most of these questions are going to be for Andy because it was a great presentation and there's, yeah, lots of cool stuff with your materials. Perfect. So yeah, I'm just going to scroll through here. I don't know if there's any you've seen already, Andy, that you want to jump on.
Yeah,
But
I see. CTAR had asked earlier about cure temperatures, and then had
yes.
lowest cure temp, highest conductivity inks. So this is something that we're actually working on and have a developmental product that is good at curing at that 120C and getting to a good value. And like, depending on what your oven is, you could, if you have a conveyor oven with IR, you could do 2 to 3 minutes. But yeah, so that's one question I saw that was relatively easy to answer. The Alchemy inks, the FS0117 might take a little bit longer, 120C, but it will reach a lower value than the developmental ink, the RD0150B. But this is kind of like the theme of what people are interested in is lower temperature, higher conductivities. So we actually have an open project that we're working on, daily to lower that temperature of the cure and increase the conductivity, which we're making good headway on that.
Yeah, absolutely. I think there's another one popped in for you. Just what's the maximum current the printed circuits can handle? I think obviously material dependent, but
Right. Yeah, and it's also geometry, dependent. What's your length and thickness, how much power is going through there. But for like the example that I had of that bus that was on the transparent heater, I want to say that's pushing like 1 to 2 amps. Mike might remember more, but I'm pretty sure it was in that range. And then for the wearable heaters that we make, you're able to run on the 1109. It's also dependent, but as an example, I had a bus on a glove that was roughly like 40 millimeters long and 7 millimeters wide, and it was able to carry half an amp.
Yeah, very cool. Great. Yeah, keep the questions coming. I'm going to try and scroll through and see if there's some older ones here as well. Yeah, I see Edmund's question. I guess all settings, once calibrated, can be saved in the library. Yeah, exactly. So as soon as the calibration procedure is done, those settings are saved like I demonstrated, and yeah, can be adjusted on the fly during dispenses as well. I saw a question about what value is the pressure setting in on Nova. It's not a specific unit. It's just a Voltera pressure unit, I guess. Looks like we might have some new ones here as well. Um, Perfect. Yeah, what are supported file formats if somebody wants to print designs apart from printable circuits, such as Gerber files? So yeah, Gerber files are the default, but we also accept SVGs. SVGs is a little bit in beta, so you'll have some mixed results. But yeah, if you do print with them, we'd love to see your results and how we can improve things there. Looks like there's a materials development one here for you, Andy, from our PARM. So particularly in the context of ink formulation, they're exploring the possibility of developing their own ink. Oh, things are jumping around on me. When when considering the optimization of these inks for printing, what factors should I prioritize? Specifically, they're curious about the compatibility of various inks with the Nova printer. Can the Nova effectively print most inks within the required viscosity range, or are there other material factors that I can consider? So I'll answer the last part really first, and then you can jump into what things they can consider. So yeah, Nova can handle a fairly wide viscosity range from 1,000 to 1,000,000 centipoise. So yeah, basically, if it's kind of a screen printable ink, it should work pretty well on Nova. Yeah, and I'll let you handle the what considerations they should think about.
Yeah, I mean, it really requires like, a very consistent particle size distribution, I would say, and understanding that is kind of important. That's one reason, a lot of the products that we have that are cavitated are less likely to clog nozzles. They're less likely to separate or settle. Just so, yeah. But as far as like in ink development, yeah, that's kind of our specialty is creating really fine, distributions in particle size and preventing things from clogging. That's why being able to print through the 50 micron nozzle, getting down to finer features, it gets complicated,
Yeah,
and even the syringe filling, isn't super. It looks easy, but there's a lot to it that you have to take into account when filling syringes.
absolutely. Yeah, awesome. Got another question from Arthur here. Is the volume weight of the Alchemy inks comparable to copper?
That's kind of difficult. Each
Yeah,
system has different percent solids. In general, we don't pursue copper or copper inks just because there's stability issues almost all the time that cause the benefit of using it to kind of go away after time and oxidization. So, there's if you did a price comparison, which we've done, of using a copper ink compared to one of the Alchemy inks, the conductivity of the Alchemy inks, especially when you look at FS0142, where you're getting, you're only like 3 to 4 times bulk silver conductivity. That's hard to compete with the copper ink, even at their price point, just because we haven't seen any data that proved otherwise at this point, and we've talked to a lot of people about that.
yeah, absolutely. Yeah. Yeah, another question here from Jeremy. Just any options for multi-layer printing? I think that's for us. Yeah, Jeremy, we recently did a video with a multi-layer print, just kind of like a little number pad keyboard. And we also have a guide in our support docs on the best tips and tricks for kind of layer printing right now. This is something we're actively pursuing and working on to improve with the machine. So it's kind of, we've got some best tips for it right now, but the current state of Nova um, isn't set up for specifically for multi-layer at this point. But yeah, it's something we're working towards. And yeah, if you're curious and have questions, you can reach out to us. And we've got that support doc at docs.voltera.io as well. All right, we've got some more coming in here. Um, could you print high frequency circuits? Um, yeah, I think this kind of a question for both of us. I think one of the examples in your presentation, you highlighted some RF applications. That's right, Andy?
Right. Yeah. Yeah. You know, the quality of your print on those type of devices, you really want to have that smooth topography, great edge definition. So yeah, and the conductivity as well, you know, can help with achieving an appropriate skin depth as you need for those applications.
Yeah, absolutely. And I will say we do have a case study on our website where we did an RFID chip. So that can be a bit of an example there. I think just for time, I think we're meaning for today's webinar to be about 45 minutes. So we've gone a little bit over. But yeah, if we didn't get to your question, feel free to reach out to either of us. We've got sales at Voltera for our end, and then Kelly at ACI Materials, Kay Fenwick at acimaterials.com is ready for your questions as well. Yeah, again, I really want to thank Andy and the folks at ACI for joining us today. It was great to do this with you guys, and yeah, just see what you've been working on with your Alchemy inks. Really great application opportunities there, and really cool to see how things have developed over the years. We will be sending out the recording of this webinar to folks. I think we're aiming for Tuesday next week because I know some place in the world Monday is a holiday. So keep an eye out for that email on Tuesday. And then just want to highlight the promo code as well. If you're looking to get Nova, you can use the promo code ACI Materials from today's webinar to save on that. But yeah, really appreciate everyone for joining us today. And I hope you learned something. I know I did. So yeah, thanks everyone and have a great rest of your day.
Thank you.